Designing smart products. In this section we'll have a look at a number of quite practical techniques and approaches that we can use to create software that we would characterize as smart. Certainly when we were thinking about considerate software in the last section, we identified a number of forms of behaviors and ways that software ideally should act, that if we're to do that, we do need to have smart, intelligent, capable software. And this opens up a very wide and really quite enriching area around artificial intelligence, when we can look at different ways of modeling behavior, different ways of predicting behavior, of adaptive learning, and so on and so forth. And certainly I would encourage you to have a delve into that sort of broad area, because there's lots of really useful and powerful techniques that can be used there to create more capable forms of software. It scopes outside the remit of this module. We're going to look at a number of quite simple, quite straightforward, but actually still quite useful techniques that we can use to create software that we would characterize as being more smart. The first one is that smart products are always thinking. And this ties into the fact that, well, I'm going to take for granted that the software that we write, we absolutely write efficient software. The algorithms that we use and all the different approaches that we do, they're designed to be efficient. And we do that for a variety of reasons. A, it's just good practice. B, we don't want our users to wait after they put a request in. We want our software to be responsive and speedy in its reply. And also, importantly, we don't want to put unnecessary drain in terms of power usage. If we're running on a mobile device, or in fact any device that uses energy, which is all of them really, we want them to be efficient in terms of how much energy is used. So they're all good reasons why we write efficient software. We also know that over the years, processors have become incredibly more powerful. So where in most situations today, not all, but in most situations, we have a setup where most of the cores are sitting there idle. We wait for the user to come along and to provide us with some input. There's then a flurry of activity, which maybe happens over a very, very brief fraction of a second, and something gets to be done. And then we go back to waiting for the user to provide their next instruction. What we should do if we want to use our software to be more smart is to use that time before the user provides the instruction to think about what are they likely to do? What sort of modeling do we have? What can we predict or preempt that the user may wish to trigger or to ask for or to look for or to act at that particular point? And we may come up with several different scenarios which are possible. And then before the user actually provides their next input, we should be working on those in the background. If it involves calculating a value, we should calculate that value. If it involves pulling down some information, we should pull down that information. So that whenever the user does then provide their next input, depending on if we're able to predict it, we'll then be able to respond even more quickly to that user's request. So we have software that is even more responsive. You might think, but isn't this inefficient? The reality is that modern CPUs, their power efficiency has massively improved. And of course we have to be considerate for other wider aspects in terms of bandwidth and related activities, but in very many cases you can calculate and prepare for several different actions in the background with relatively minor cost. And it doesn't really matter if most of them are thrown away or all of them are thrown away, because it's the overhead associated with doing it is sufficiently minimal that we can accept that. When we can do this and when we can preempt accurately what the user is likely to do, it's incredibly powerful then to create even more responsive software. Smart products have a memory, and this ties into a lot of the aspects that we talked about when we were thinking about considerate software. Typically, at the minute, if you think about average software, where it does store values, these may be settings, or there could be other variables that are cached just because they help the operation of the program. Most often, we don't store information about how the user has interacted with us in terms of their preferences, what they did, why they did it, when they did an activity, what they went on to do after that activity. we should make use, because again, memory is quite richly available today, so we should make use of that memory to store information appropriately on how our user interacts. And of course, we're doing this as considerate software, so we're telling the user about all of the activities, we're letting them control how and what we capture, and we're advising them very closely about what we do with it and the protections that we associate with that. Of course we do that. But if we are recording this information, that gives us a really, really rich data set on top of which we can then more accurately predict what the user will do next. We can more accurately answer, well, what should our default options be from here? We should more accurately be able to piece together why the users are doing things or what their overall goals are, because it gives us that more holistic set of data that's collected over time that enables us to have a much more rich interaction with our users. And the final slide in this section is that smart products anticipate needs. And that's kind of a given then from the previous two. If we are storing information about how our users interact, if we are calculating things up front, we're preempting behavior, then, but both together, it means we are anticipating the needs of our users. And the reason, if we actually model this, users tend to be quite repetitive and quite predictable, certainly in the vast majority of their normal behavior with an application. They would have a normal standard workflows where they'll click here, they'll look this up, they'll do that. For capturing these things together, we'll not get all of their behavior, that doesn't matter. We will get the things that the users do commonly and repeatedly. And that's what really matters, because these are the things then, if we can speed up, there will be a significant benefit to the user because the user does them commonly and repeatedly. So we have a number of examples here just to show you how we can anticipate. So if we've got a set of options that we always normally present to the user and the user always selects a particular font or particular size, let's just default to that font, default to that size. Or not even present it at all, just to go ahead and let the user tell us if we've got it wrong. More interesting, but also more difficultly, if we see a series of actions that always go together, so more primitive actions, the user opens up this dialog, puts this in, calculates that value and does this, and they consistently follow that series of steps. Almost certainly from the user's point of view, that represents a higher level compound action that they are representing or expressing through several individual steps. If we have a way of identifying those and then bundling up to the user as a single step, a single action, that would be a really fantastic way of improving usability and letting the user know that we have software that is smart enough to understand the interactions and then to optimize the interactions that it's having with the user. So that's all we want to cover. It's a few practical examples about how we can create more smart software. It's a massive, in-depth area, but hopefully this gives you a few useful pointers. In the section after this, we're going to go on to think about social products. And if we want our software to behave in a way that is socially aware and socially supportive, well, what exactly does that mean in terms of its behaviors?